Hi, in this video we will learn about the Charliers checks for moments. Here we have our table of the class intervals, and these intervals are actually talking about heights of some people. And this class interval in the first row, you can see that 144.55 to 149.55, that means the width of this class is actually 5. The same width goes with the other class intervals also, that is 5. And in the second column, you have the class mark, that is xi. Now this class mark is actually nothing but the midpoint of these class intervals. That means 147.05 is the midpoint of this class interval. 152.05 is the midpoint of this class interval. 149.55 to 154.55. Now we have these class marks here, or the midpoints here, and in the third column we have the frequencies. That means this midpoint 147.05 appears only once. This 152.05 appears for 3 times, right? Now this is our assumption that these midpoints actually occurred in these class intervals, right? Why? Because we do not know exactly what was the data point between these intervals. That means if you take the first row, we assume that the midpoint, that is 147.05, was the height of the person. But we actually do not know exactly what was the height of the person. But we have this information only, that the height of the person was between 144.55 and 149.55. Since we do not have the exact height of that person, we assume the midpoint of this class interval to be the height of that person. And with this height, 147.05, that is within this class interval, there is only one person in our collection. So we have written 1 here. On the second row, the same problem goes. We do not know exactly the heights of the persons who are appearing between 149.55 and 154.55. But we have this information that there were 3 persons whose heights were between 149.55 and 154.55. So we have written 3 here. But since we do not know exactly the heights of those 3 persons, we are assuming that the midpoint of this class interval to be the uniform heights of those 3 persons. And due to this assumption, there will be an error. So that is a grouping error. So we have already discussed how to tackle this grouping error and how to correct the moments or the moment calculations when we learned in the previous video on Shepard's corrections for moments, right? So if you missed that video, you can have a look how to correct the errors due to this assumption, right? Now, if we add these frequencies, we get this 177. That means there were 177 persons from whom we have taken these measurements, right? Now, this column is talking about the UI. That means you have changed the origin as well as the scale. Now, why we are changing the origin and also scaling the deviations down by some scaling factor? This is just for simplification. If you go like this, then your computation will be much easier. And that is the reason. Now, what is x suffix 0? X suffix 0 is actually a value which is central to this list of values, right? It does not to be necessarily a mean, but you can have some central value by looking at these numbers, right? Now, you see that there are 8 numbers here, and these are all ordered. So, you can have this 162.05 as the chosen x suffix 0, as we have done here. And if you wish, you can go with the 167.05 also, and that will do no harm to you, right? So you can take 167.05 in place of 162.05 as the origin. Now, regarding this denominator 5, which is h, you can take any integer, but we prefer the width of the class intervals to be the denominator, because this will give you an easier computation, okay? Now, for computing moment about any arbitrary point A, and in this case, if we take 0, which is also known as raw moment, we have this equation for first order moment. You see, m suffix 1, this 1 indicates that your moment is of first order, and this dashed indicates that this moment is about some arbitrary point A. If the dashed is not there, then you will know that the moment we are talking about is about central moment, which is about mean. Okay. So here we have this arbitrary point 0, that is, we are dealing with raw moment, and you have this expression that 1 by n summation of ui dot fi, and you multiply this whole term by h. Next, you have this moment of order 2, and the same thing goes, just ui raised to power 2, and here also h is raised to power 2. This is the third order moment, and this ui is raised to power 3 and h raised to power 3. And here the fourth order moment, and this ui is raised to power 4 and h is raised to power 4. Now the question is, why we are multiplying this deviation by h, or here h square, or here h cube, and here h raised to 4. Let us see one of the slides in one of the previous videos. When we were learning the effect of change of origin and scale on moments, we got these two equations. The first equation is the deviation about any arbitrary point, and the second one is the deviation about mean. So what we got about arbitrary point? You see, xi minus a equal to h times ui. That means you multiply this ui with the interval h, and you will get the original deviation, that is xi minus a. And the second one is talking about mean. We are not interested with the second one in this video, so we will concentrate on the first one only. That is why we are getting this. Every time we are getting this summation and this mean deviation, we are multiplying that by h to get the original deviation, and that will be our moment, right? So to compute the moment, you need this summation of ui and fi, right? So we get this ui and fi here. That means you multiply these two columns, that is minus 3, this one, multiply this with 1, and you get minus 3. Here also minus 2 is multiplied with 3, and you get minus 6. So in this way you get all the ui dot fi's, and you get this summation 95. Next, you get this ui square dot fi for this second order moment. So ui squared means minus 3 squared, that means you get 9, and 9 times 1, this fi will give you 9. Here also minus 2 squared will give you 4, and this 4 times 3 will give you 12. So in this way you get this column filled up, and you get this summation as 263. So this 263 will help you to get this moment of order 2, right? This one also, ui raised to power 3 dot fi. That means your ui is here is minus 3 raised to power 3. That means you will get minus 27. And this minus 27 multiplied by 1 will give you minus 27. Here, minus 2 raised to 3 will give you minus 8. And this minus 8 when multiplied by 3 will give you minus 24. In this way, you fill up all these cells, and you add these values, and you get this 383. And this 383 will help you to get the moment of order 3. In the same way, you go with this one, ui raised to power 4 dot fi. You fill these cells here, you add these, you will get 1319. You plug this 1319 here inside this expression, and you will get the moment of order 4. Now you can plug these values, this 95 here, here. That means this one will look like 1 by 177 times 95 times 5, and you will get the moment of order 1. Here also, to get the moment of order 2, you write like this, 177 times 263 now, because this ui square fi is giving you 263, this whole summation, and you multiply this by h squared, that means 5 squared, right? Now if you go on computation of this, then you will get the moment of order 2. And similarly, you can have this third order moment and the fourth order moment. Now the question is, are you sure that whatever you have done here, all these calculations, all these values are correct? So before going for the final computation of these moments, by plugging in these values, you must have a check whether these values, this 95, 263, 383 and 139, these are all correct. Here, Charlie has suggested one technique for checking these values. Now let's see how it works. You add one more column here, And this column is going like this. You add 1 to the EY and then you get this raised to power 4 dot Fi. Now why we are going like this, that raised to power 4? Why not power 2 or why not power 3? Now the point is, if you have the intention that I have to check all these columns and all these added values, then you have to use this power 4 here. Because if you have this here, that's power 4, then it will check from power 1 to power 4. Now if you have this 4 to 3, then it will check from 1, 2 and 3. It will not check the 4, right? Similarly, if you have this 2, then it will check only these two columns, 1 and 2. So if you have any power p here, then all the columns starting from power 1 up to power p will be verified. Okay? That is why to check all the columns, we are using here power 4. Okay, let's fill up these cells. So this column is actually dependent upon these two columns, right? That means you have this EY from this column, you add 1 and multiply that added value with this Fi and you will get the value here. So minus 3, this is the EY, plus 1 will give you minus 2 and this will be raised to 4 and you multiply this by 1. So minus 2 raised to 4 will give you 16. So 16.1 will give you 16 here. One more I will show you. Minus 2 plus 1 will give you minus 1. And this minus 1 will be raised to 4 and multiplied by 3 because here the Fi is 3. So minus 1 raised to 4 will give you 1 and multiplied by 3 will give you 3 here. In this way, you fill up all these cells and you will get this. And you add these values and you will get 4986. So you have this EY plus 1 raised to 4 dot Fi and all these summations as 4986. Now to get this 4986, this summation, you did not touch or did not consult the values from here. Now this question may arise that if we have this summation here and it is totally dependent upon these two columns, this Fi and Ui, then what it has to do with these columns? Because we are interested to check the values from here, not these things, right? Yes, we have a connection between these four columns and this last column. You apply binomial expansion to this term because this is a binomial form, right? Because this is the first term Ui and the second term is 1 and this power raised to 4 is actually our n. So if you expand this Ui plus 1 raised to 4 using the binomial theorem, then you will get this. And what is there inside? You see the terms Ui raised to 4 dot Fi, the summation of this. So you have this Ui raised to 4 dot Fi and the summation is 1319 plus this one 4 times summation of Ui raised to 3 dot Fi. So here you go, Ui raised to 3 dot Fi and this summation is 383. Then the third one 6 times Ui raised to 2 dot Fi, the whole summation, and this is 263. And this one is 4 times summation of Ui Fi, which is 95. And the last one is summation of Fi, that is actually n, which is 177. So you can see that this Ui plus 1 raised to 4 dot Fi, the whole summation, is having a link or connection between these four columns, isn't it? Now, on the left hand side of this equal to sign, we have got 4986 without consulting these four columns. Now, we will go for computation of this side, that is the right hand side. And now, if we plug in these values, this 95, 263, 383, 139 and the summation of Fi, that is 177, and if our values are correct, that means whatever we have done here all are correct, then this will also give you 4986, right? And if you have a mistake somewhere here, then this expression will give you a number or the value which is not equal to 4986. So, based on these 4 columns, we get 1319 plus 4 times this 383 plus 6 times 263 and 4 times this 95 and this last one, this summation of fi, that is 177. And if you add this, you get 4986. That means all our calculations here, whatever you have done, are correct. Now you are sure about these values, you can go ahead with the computation of the moments, right? So, why we are going for Charlier checks? To verify correct computations of moments in a table of grouped classes, to guard against computational mistakes. Now, why you are going for UIs? This is just for simplification, where x suffix 0 is a chosen origin that does not necessarily to be a mean, but you can have some central value from that list of numbers. And here h is some integer, some suitable integer you can have. Generally, people used to take this h as the class width. And this class width you can take only whenever all the class intervals are equal. But whenever the class intervals are not equal, then you have to choose a suitable integer, right? If you want to check this expression, summation of ui.fi for computation of the first order moment, then you add 1 to this ui plus 1.fi and you expand this and you will get summation of ui.fi plus summation of fi. Now you can see that if you have this expression or if you have this value directly from the table and you have this value, the computed value here also, and you can match it. So if both the sides are coming the same values, then you will know that your computation for this summation of ui and fi is correct. If you want to check this ui fi, there is a first order. Also, this ui squared.fi, that is for the second order, then you can have ui plus 1 squared.fi, and this will help you to check this second order term as well as the first order term, because you can see that here the second order term is here as well as the first order term is here, right? So both the terms will be checked. So you do not have to go for checking these summation of ui fi, this is a first order term, in a separate way like this. The same thing goes with the third order moment. If you have to check the third order term like this, and if you expand like this with the third order term by adding 1 and this ui plus 1 raised to 3, then you will have all the third order term, the second order term and the first order term checked. Okay. The same thing goes with the fourth order terms. You add 1 to the fourth order term and you will get all these terms. As you have seen, the fourth order term is checked. That means this one is checked. Here also third order term, this one is also checked. Second order term checked, and the first order term is also checked. That is why we have taken the fourth order term in our example to check all the terms starting from order 1 up to that order 4. Now regarding this summation of fi, we already know that these are actually n's. So in text you will find they have written summation of ui fi plus n in place of summation of fi. So do not be confused. So this ends this video. If you have any kind of question regarding this Charlier's checks, you can write me in the comment box. In the next video, we will go for learning skewness of a distribution.